students, welcome back. Now let's get into our next diagram, that is the class diagram. A class diagram is a type of UML diagram that shows the static structure of a system. So we can think of it as a blueprint of an object-oriented system. It tells us what classes exist in the system, what attributes of the data and the methods of the functions they have, how classes are related to each other, and so on. So the common way of presenting a class is a rectangle with three parts. The upper part is the class name, then in the next part we have attributes, and the last part we have the functions or the methods. The attributes are of three types. It may be private, public, or protected, and same way the methods may be private, public, and protected. So depending on the component is to be visible to which part of the world these are shown. So the private one are visible only within the class. Private variables are visible only to the functions or the methods defined under the class, whereas the public are the one which can be viewed even outside the class about some object-oriented properties. Then we have relationships between the class. It may be an association, that is a simple connection, that is customer is related with order. So every order should be created by a customer. Multiplicity shows how many, that is one customer may have multiple orders, but any order should be given by only one customer. Inheritance or the generalization, that is the child class inherits the properties from the parent class. So admin and the customer inherit from the user. So this simplifies the working if we can go for inheritance. And then aggregation or composition, that is whole part relationship, that is an order contains many items. So when you talk about an order, it contains many items. So if we want to put that clearly, then we have some symbols used for that. So for aggregation we have this, that means the class B has a class A, and here the class B owns class A, and here we have class B is inherited from class A, and so on. So dependency is a class uses another class temporarily. So why do we require the class diagrams? So they provide a very clear picture about the structure before coding begins. So that helps the developers to see what data and behaviors exist and show how different parts of the system interact with each other, and it serves as a documentation for maintenance. Now the question is how to create the class diagram. As we said in the beginning, earlier when we started working on the UML diagrams, we said that the first diagram we are going to draw is use case diagram, and others diagram we just derive out of the use case diagram. So we'll continue that in the same lines and see how to create a class diagram from a use case diagram. So the first step is start with the use cases. So from the use case diagram, identify the actors. So suggest the interfaces or external classes. So actors suggest interfaces or the external classes. They are not internal classes, they are external classes because they are outside our system boundary. So they may suggest about the interfacing to the external world, or they may be talking about the external classes, and the use cases suggest the system operations or the responsibilities. So for example, if we talk about the fraud detection machine learning system, then use cases are the detect fraud, train model, generate reports, and the actors here are the customer, bank employee, fraud analyst, and so on. The second step is to find the candidate classes. So look at the nouns in the use cases, requirements, and the descriptions, like customer, transaction, model, report, fraud detection system, and so on. These are the nouns we find across these use cases, and these can be potential candidate for the classes. And these nouns can often become the classes. Then third step is define the responsibilities or the methods using the use cases. So look at the verbs or the actions in the use cases. So in the case of detect fraud, detecting a fraud can be a function. So we can create a function or a method called detect fraud in the fraud detection system class. under this class we can create one detect fraud method. So if the use case talks about train model, then we can create a function called train model in the model trainer class and so on. So if we are talking about generate reports, then we can create a function called generate report in the report class or fraud detection system class. Then the fourth step is to add the attributes for these classes. So think about what data each class must maintain. So the class must maintain various data. Just try to identify what all the data the class must maintain. Like a customer, maybe one class, then the attributes may be customer ID, name of the customer, account number of the customer, and so on. So these can be the attributes. If you talk about transaction as a class, then transaction ID, amount, or timestamp, etc. can be the attributes. If you talk about model as a class, then model ID, accuracy, version can be the attributes. If report is a class, then report ID, report date, fraud cases are the different attributes that a report class can have. Then the fifth step is to establish the relationship. We look for associations. That is, example is customer makes transactions. So there is a relation between customer and a transaction. So for a transaction to happen, there must be a customer. So there is dependency, like fraud detection system uses model to detect the fraud. So the fraud detection system depends on the model. So there is dependency. Aggregation or composition, that is report includes many transactions. So that's aggregated form of various parts. Then inheritance, like the bank employee, fraud analyst, may both inherit from the user. So the things which are common for a human being, the attributes which are common for a human being, the functions which are common for a user can be dumped onto the class user. And the bank employee and the fraud are the two different types of users, so they can inherit properties from the user, and only the additional things that are required for a bank employee are put under bank employee class, and fraud analyst requirements are put under fraud analyst class, and all that. That simplifies our building. So examples. So customer classes. The customer is the class. The attributes are ID, name, methods. You can use make, then transaction, make transaction. Then transaction is a class. The attributes are ID, amount, time, and the methods are get detail. Fraud detection system is a class. The attributes are system ID. Methods can be detect fraud or given a transaction, generate the report. If model is the class, then attributes are the version, accuracy. Method is the train, and train model, given the data, update model. If the report is the class, then attributes are report ID. Fraud cases, method will be display report. And if so coming to the relationship, there is a relationship between customer and transaction. So one customer can have many transactions, so this is one to many relationship. Fraud detection system has connected connection with the transaction. It is used for analyzing. So fraud detection system is connected with the model. It uses this fraud detection system as a connection with the report. So there is a relation between the fraud detection system and the reporting system. So it creates the report, and fraud analyst is related with the model. Here the fraud analyst trains the model. Bank employee is related with the report. Bank employee here reviews the reports. So if overall if you look at it, we begin with the use cases, and from the use cases we identify the classes, that is the nouns, and then we identify the methods which are verbs, and then we identify the attributes which are data and relationships, and then finally draw that diagram. So some examples from the use case and to the class diagram. So here the actor is customer, so the class is a customer. Actor is a bank employee, the class is bank employee. It is inherited from the user. Fraud analyst is an actor, so class is fraud analyst, and it is inherited from the user. And the use case is detect fraud. The method is detect fraud in the class fraud detection system. we have use case like train model. So the method is the train model in the model class. So we have use case like generate report. So we can have a method called generate report in the fraud detection system or the report class. So the key idea is the actors often map to the classes and use cases map to the methods in the system classes, and domain nouns become classes like transaction, model, report, etc. So take an example for use case like place order. So the classes here, we have a customer, we have order food item, we have restaurant, we have delivery agent, a payment, and the relationship. So the customer places the order. So the relation is between customer and order, and the relation is placing, and the order contains food items. So this is one to many, and then we have order is delivered by a delivery agent, and the order is paid via a payment gateway, and the food item is offered by some restaurant. So these are the various relations. Now looking at the example for online shopping, the classes are customer, product, cart, order, payment. Relationships are customer, places order, order includes product, cart contains the product, and so on. So that's the class diagram, how it looks like for online food ordering system. So we have customer, we have category, we have delivery person, there is an order, there are items, and there are offers, there is restaurant. So all these are related. So one customer can have one order, and that order is delivered by one delivery person. So the order can contain any number of items, and these items may be having different categories, and one restaurant may have multiple items. So that's how the class diagram can be written up for any given use cases. So if we take one use case, and for every use case we break down into the nouns and the verbs. Nouns we can become the classes, and verbs will become the methods, and attributes of each noun can be identified, and they become the attributes. So that's about the class diagram, how class diagram is built from a use case diagram. Thank you.